Carbon dioxide, Mr. Speaker, is a natural byproduct of nature. Carbon dioxide is portrayed as harmful, but there isn't even one study that can be produced that shows that carbon dioxide is a harmful gas. There isn't one such study because carbon dioxide is not a harmful gas, it is a harmless gas. Carbon dioxide is natural, it is not harmful, it is a part of Earth's life cycle.
In the contentious debate about man-made global warming, all sides agree on the physics of the greenhouse effect. It can even be demonstrated in the lab using a FLIR thermocam, a special infrared camera.
So we're going to demonstrate to you how the CO2 absorbs infrared radiation, which causes the Earth greenhouse effect. Infrared radiation is another word for heat radiation, which is coming off my face and which is picked up by a camera that I'm looking at. The camera is sensitive to heat radiation. Between me and the camera is a volume that we will fill with CO2 gas. And as we turn on the gas, my image will slowly fade.
This physical property of CO2, known to physicists for a century, is the bedrock of the concern about global warming. Because the ordinary air in the tube, composed mainly of nitrogen and oxygen, does not block infrared radiation, the camera sees the heat coming off the scientist's face clearly.
And as we turn on the gas, my image will slowly fade.
But when the tube is filled with CO2, or any greenhouse gas, their molecules absorb the heat radiating off his face, blocking its path. As less and less heat reaches the camera, the image fades. If the scientist were surrounded on all sides by CO2, then the effect would be for him to get warmer, like the Earth in space.
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera which is purring away here. A candle, this glass tube which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor the camera picks up the flame perfectly. Look at that, the hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide.
Just keep your eye on the flame.
The gas is invisible, so you don't see it fill in the tube. But as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat.
The candle's warmth no longer reaches the camera. Instead, it's absorbed by the carbon dioxide inside the tube. That's exactly how carbon dioxide works in the atmosphere. It traps heat, preventing it from escaping into space, and warms the atmosphere in the process. The more carbon dioxide there is in the air, the more heat is trapped. This is the greenhouse effect.
But why should adding an invisible, non-toxic gas be cause for concern? Compared to the major atmospheric gases, oxygen and nitrogen, the amount of CO2 is minuscule. But through an accident of physics, the greenhouse effect, its consequences are significant. Perhaps the most dramatic example of the greenhouse effect is the Earth itself. But for this effect, the Earth would be frigidly cold. Of the energy coming from the sun, about half of the light gets scattered and absorbed before it reaches the surface. The rest is radiated back as heat or infrared radiation. In the absence of a greenhouse effect, this heat energy would escape back into space, leaving the Earth with an average temperature of 0 degrees Fahrenheit. All water would freeze. The reason this doesn't happen is that greenhouse substances, gases like carbon dioxide and methane, and water vapor and clouds all act to trap escaping infrared radiation. The net effect is to cause the Earth's surface to warm up to an average of 59 degrees.
It's as real as gravity, and it keeps the planet habitable. We'd have an average surface temperature on the Earth below the freezing point of water were it not for the greenhouse effect.
We've calculated that if you double the number of CO2 molecules in the air, it's the equal amount of energy to putting a little kid's 4-watt nightlight in every square meter of the planet. So that's not a lot, these little 4-watt nightlights, but if you put one every square meter on the whole planet, you'd expect that to warm things up. When we say we expect extra CO2 in the atmosphere to warm the surface of the Earth, we're saying adding energy to something changes its temperature. You know, we could argue about how much it'll change or when it's going to change, but the idea that putting extra CO2 in the air will warm the surface is pretty much of a no-brainer. You add energy to something, it changes its temperature.
The radiative properties of greenhouse gases are among the most solidly understood bedrock principles of physics. The CO2 laser tools used in industry don't work by magic. They work because of our comprehensive understanding of the behavior of CO2 molecules. Scientists know that Earth's great ice ages have been triggered by changes in the Earth's orbit and axial tilt. But without greenhouse gas feedbacks, there is no way to understand the huge swings between glacial and interglacial periods. Billions of years ago, our young sun was only 70% as warm as today, yet the fossil record shows that the Earth maintained liquid oceans at the time, impossible without a CO2 greenhouse effect, as paleoclimate expert Richard Alley explained recently to the American Geophysical Union.
And that really, if you leave CO2 out, nothing makes sense. If you put CO2 in, a whole lot of it makes sense, and then you can put the other pieces into the puzzle and make it work. If you try to keep the liquid water on the surface of the Earth with 70% of modern sunshine, if you try to do that by changing the Earth's albedo so we soak up more sun, it has to be perfectly black. And a perfectly black Earth is not going to work. And so in point of fact, what we do is we know from geologic evidence that there is liquid water way back. And that in turn means we have to have a stronger greenhouse. We don't have sort of pound on the table, this is nailed, we're done on this one yet. But the best explanation is that this CO2 thermometer, the thermostat, is what has kept us with life in liquid water for 4 billion years.